I'm just going to walk you through homework 6, and I think it's one of the easier ones. It's pretty straightforward. Anyway, the main idea is that you have a CPU, and it has its own code, and the code is what you wrote back in homework 2, 5, and 4, or whatever. And it has other devices that are connected to the CPU. So let's say, for example, it could be a mouse, a keyboard, webcam, or tablet. And in Vesp, you're going to have 8 devices, starting from device 0, 1, 2, 3, 4, 5, 6, and device 7. And each of these devices will have their own code that they want to run. So let's say, for example, device 1 and 7 is on. What's going to happen, or the problem is, which code is it going to run first? So what's going to happen is that the CPU is going to run 5 main cycle or 5 instruction from its own code. And after it runs 5 instruction, it's going to look and say, hey, which devices are on? In this case, device 1 and device 7 is on. So it's going to be like, oh, which one should I run? Well, device 7 has a higher priority than device 1. So the CPU is going to run all of the code from device 7. And then after it finished running all of the code from device 7, it's going to run 5 more main cycle or 5 more of its own instruction. And again, it's going to look back and it's going to be like, hey, which devices are on? In this case, only device 1 is on. So it's going to run all of the code from device 1. And then it's going to move back to running its own code. And that's pretty much the whole concept of this homework. So device 0 has the lowest priority and 7 has the highest priority. So let's get straight to the code. So what you're supposed to do for this homework is you're going to have to edit the code for your device number 4 and your device number 5 and your device number 7. So the code for device number 4 should display a picture. The code for device number 5 should display another picture. And the code for device number 7 should clear the screen. And it should look something like this. So I want to run the code for device number 4, and I want to display an image of this cup. And for device number 5, I'm going to display the image of a fish, and device 7 should clear the screen. So let's run device 4 first. So 0, 1, 2, 3, 4, 5, 6, 7. And make sure you have a spacebar at the end. And there it is. It displayed the cup. So let's now run the code from device number 5. So 0, 1, 2, 3, 4, 5, 6, 7. And do not forget the space at the end. And it drew the fish. And all of these are just the old pixel data that I didn't clear yet. So it worked. So now I want to run the code from device 7, which should clear the screen. So 0, 1, 2, 3, 4, 5, 6, 7, and a space at the end. And don't worry about all of these code. It's supposed to happen. And there you go. It cleared the screen. So that is pretty much how the homework should work. So now the question is, how do you do that? Well, the first thing you need to do is get Vesp 3.0. Vesp 3.1 works too, but I think 3.0 is just better for this homework. Second is pick 2 pictures that you want to draw. For me, for this example, I'm just going to do 1 picture, and I want to draw this duck over here. And the next thing you need to do is download interrupt v0 all the way to v7, and it should be in the class folder. Just search up for interrupt. and they should appear, and just download all of them from 0 to 7. Then after that, you want to put all of those vectors inside a folder named interrupt vectors, all lowercase, no spaces, and it has to be spelled exactly this. So after you're done with that, you could start writing the code for your devices. So the only file you need to worry about is interrupt v4, v5, and v7. So for v4, you should write a Vesp code that draws the picture. And you would notice that in all of your interrupt vectors, it has a 7900 and 7800. So 7900 just say that your code for the interrupt vectors start here. And 7800 just tells it that the interrupt vector, the code for it, ends here. So all of your code needs to be between these two numbers over here. And another thing that you need to watch out for is that you have a maximum of 64 lines of code. So do not exceed 64 lines of code. And that's all you need to worry about. So anyway, to draw the picture, you would need to look at where these pixels are located. So if you look back at the cheat sheet, row 0 of the screen, like somewhere up here, this row over here, start at address 300, and it ends at address 3FF, which is the pixel somewhere over here. So address 30 is the pixel over here, address 301 is the pixel right next to it, 302 is the pixel right next to that, and so on, 303, 304, 5, 6, 7, all the way to 3FF, which is the pixel over here. And row 2 of the screen starts at address 340, which is the pixel somewhere over here. And it ends at 37F, which is over here. And row 15 of the screen, which starts at address 6C0, which is going to be the pixel somewhere down in the corner over here. And ends at 6FF, which is the pixel somewhere at this corner. So you have to look at your picture and determine which pixel do you need to place down and at which address do you need to put it at. So for this one, where's my thing? So address 300, there should not be any pixel, so I could just ignore that. At address 301, there's that underscore. So I'm just gonna find the ASCII value for the underscore is 5F. So I'm gonna load into address 301 the ASCII value for the underscore. Then I'll look at the next pixel, which is another underscore. So I'll load into address 302, another underscore. And you're going to do this for all of these pixels over here. Then you move on to the next line, which is a /, which has an address, a hex value of 5C. So row 2 of the screen start at address 340. So 340 will be nothing. 341 should be a /. So I'll load into address 341 the ASCII value of 005C. Right? Yep. And then I'll do that for this pixel and this pixel and this one and then this one. So you're going to do that for vector 4, interrupt v4. And then you're going to pick another picture and do the same thing for interrupt v5, which is this file over here. So after you do that, you finish the first two parts of the problem. For me, what I did was I just wrote a C code that will compile the image for me. So I have my image over here. I stored it in a file called image01.txt. And what my code does is that you input in the file and it will output a file that contains all the code that will draw out the image. So this is like the second option that you could do, but I think the easier way to do it is just to pick a really small picture and just draw that. Anyway, so after you finish drawing your picture 1 for V4 and picture 2 for V5, you're going to move on to vector number 7. And write a code for it. So the code for vector 7 should clear the screen. And to do that, you're going to need to start at address 300, and you're going to loop and scroll through all the way to 6FF. And as you're looping through, you should put the ASCII value 0x20, which is the ASCII value for the spacebar, in every single location, and that's how you're going to clear the screen. So it should look something like this. For I is equal to 300, I is less than or equal to 0x 6FF, I plus plus, mem of I is equal to 20, which is the ASCII value for the spacebar. So you're just going to loop through all of these addresses and fill them in with spacebar character, and that is how you're going to clear the screen. And that's pretty much how homework 6 will work. I think it's really straightforward. So you should be fine doing it. Well, thanks for watching.